Good morning, this is Miss Gonzalez. Today's near activity is going to be about the functions and their attributes. We are going to break this section 1.2 into 2 days. Today, most of what we do today should be a review from Algebra 2. Hopefully you remember it. If not, hopefully you will have a better understanding of it by the end of the near activity. Like always, you will have a quick video, then a little check-in, so to speak, for you to do afterwards. It shouldn't take you that long. Next class, we will actually do some of the Pearson questions and look deeper and apply these notes that hopefully you are taking. As we go through each video, please make sure you are taking notes in your notebook and having a notebook and a reference to look back at as we go through this unit. Okay, so this first quick little video is everything that you see here. I am going to make it a little bit larger. You guys said you couldn't see everything great during last near activity, so hopefully you could see all of that better. So a function, hopefully you guys all remember what a function is. These are what you see here in the typed black lettering is the key vocab that we're going to look at in this first video. Okay, so a function is a set of ordered pairs where every input is assigned exactly one output. In other words, the x's can't repeat. Hopefully you all remember that. Okay, so function notation, remember, is f parentheses x, which is read f of x. So f of x is just another fancy way of saying y. They mean the exact same thing. That is important to remember. It's just a different way of writing it. It's saying the function of x, whatever x did, gave you the outcome y. F of x is your outcome. Okay? So if you remember, vertical line test is basically checking to see does the x repeats. Because if your x repeats, then it's not a function. So I'm going to do, let's do the red. If I was to do a bunch of vertical lines, usually your pencil is the best vertical line you always have. You're looking, does it ever cross more than once? Well, that first one, no. What about the next one? If I was to keep moving this vertical line anywhere, am I ever going to cross this squiggly line twice? The answer to that is no. So for both of these, this was a function because nowhere in here did my x repeat. This is a function because, again, nothing here, my x repeated. This, however, hopefully you are all screaming out, is definitely not a function. I repeated not once, not twice, but 3 times. Okay? All right. So now to move on, hopefully, that is back to Algebra 1, so hopefully you all remember how to look and know whether a function is a function or not. A graph is a function. We also have a mapping diagram. So a mapping diagram, say I had 1, 2, 3, and 4, 5. Everything has to be assigned. Every x needs to have exactly one output. In this case, this does. If I was to flip this around, and now I have 2 right here, and that would no longer be an output. I'm going to do this a little bit bigger. This would no longer be a function. As you could see, the 1 repeated, which was the x here, therefore it is not a function. So those are 2 ways to look at whether or not you have a function. Now we're going to move on to domain and range, which again, hopefully is a review. Now I have put both because just like your textbook last year and your textbook this year, they like to talk about both set notation and interval notation. Depending on your teacher, you probably did a lot with set notation, or if you had me, we did a lot with interval notation. I personally prefer interval notation. It's just a little bit easier for me to write. I would find that this textbook also prefers interval notation because I see a lot of questions saying in interval notation throughout this. Okay, so domain, remember, is set of x values. I like to tell you if it's interval notation, you're saying what is happening all the way to the left and what is happening all the way to the right. So you get parentheses for open circles. That would also be these if we are talking about set notation or infinity. You have the closed brackets or the bars underneath. When it is a closed circle, or the graph touches that point. Okay, so what I am going to do is look at, I'm going to look at this one and this one for interval notation and set notation. Okay, so if we look at this first one, and I was to extend these arrows, because that's what graphs do, they go on infinitely in both directions, and I was to continue this and continue this, what would be the furthest to the left over here? Well, that would be negative infinity. What would be furthest to the right? Well, that would be positive infinity. Since you can never reach infinity, we use parentheses. Okay? Set notation, it says x such that x is in the set of all real numbers. That is set builder notation. A lot of times we just say this part here and don't have the whole set builder notation. Especially for all of these homeworks, I highly recommend that what you are doing is looking at the directions and reading which one they prefer your answer in. Okay, now your range, as we wrote, is bottom is the set. Write it. All y values. And in the same sense, I like to write bottom because it's always the smaller number that comes first to top. Again, all of your symbols that I wrote down here are still valid. So interval notation for range, if again I follow these values all the way down, I am not going to find a bottom. So my bottom is negative infinity. If I follow this graph all the way up, again, I would have positive infinity. Now, depending on what this actual graph is, one could argue that it is a pattern that is still going up and down, up and down. So if it was to go up and down, I would accept in this one, which is why your work is always good, that this actually goes at a bottom of, I'd say probably negative 1.8, which it touches, to a positive 1.8, which again it touches. So I would accept either one of those answers for that graph because it's hard to tell whether or not it goes. Now for this first graph, there is no doubt, because there is no pattern, that this would continue on and would be the set of all real numbers. The middle graph I can argue either way depending on how you look at it. Okay, so set notation would now say the y value such that y is in the set of all real numbers if you thought that it continued on and on and on, or you would say y such that y is in between, so we had negative 1.8, y is in the middle, to positive 1.8. And either one of those I would accept as the true answer. Okay? Now I am going to erase some of this graph. And I am going to do domain and range of the two up top functions and interval notation for the first one and set builder notation for the second one. Okay, so for this one, again, if we extended our lines, the domain would go from negative infinity to positive infinity, because furthest to the left, I'm never going to find it. Furthest to the right, again, I'm never going to find it. The range, if I go down, again, because if I extend this, I'm never going to find it. And the top, I'm never going to find it. So that would be my domain and range. Even though the graph looks like it has peaks, you have to remember that they go on infinitely in both directions. Okay? The next one is a little different because this line actually is, even though it's going off infinitely in both directions, it's not going down. And the same with this side if I was to extend it. So for my domain, I would still say furthest to the left, I'm never going to find it. So I'm going to say x such that x is in the set of real numbers, just so you are seeing both ways to write this. And range, if you look at it, where did I extend my lines? This is extending, but not going past this value. This one's extending, but not going past this value. So I would say that the range is y such that y is in between negative 3 and positive 3. Okay, so now you have a couple questions talking about function versus not function and domain and range. If you have questions, we will go over it next class.